Good day, everyone. My name is Fernando Zagatti. I'm a mining engineer here at DataMine Africa, and I'm glad to be presenting you the second session of our DataBlast webinar, a complete workflow with the whole drill and blast process being done on our software. Okay, so this is our drill and blast solution, and I hope I can assist you to understand how our tool works, and I hope you enjoy it. I am here presenting the DataMine product range. Okay, I'm not going to spend too much time here, but it's important to emphasize that DataBlast is an operation software, so it can work as a operation tool, but it can also work as a scheduling for the blocks on the drill and blast side. Okay, so it's not just an operation, it can also work as a planning tool. Last week we had the first session where Aaron talked about a lot of things. It's a complete overview about the software, and he's showing there a lot of important features, a lot of important add-ons that we have on DataBlast, and what's best for your operation. Okay, he's a very experienced guy. He's been working for almost 15 years, and I'm sure you will enjoy as well. If you haven't already watched, please go there and watch us on the GoToWebinar page. Okay, today we're gonna talk about a complete workflow in DataBlast. So it comes with the design, then drilling, then measuring, then charging, then initiating. Okay, the whole thing is that can be done on DataBlast as a workflow in the drill and blast operation side. Okay, so let's go to the software and see there how it works. Okay, so this is what we are going to do on the software. We start with the design, then we get the drilled information, then we get the measured information, we move to the charge information, so we get the whole information from emotion and info if you have any, the stemming heights, everything, and then we time the block. Okay, so we can have some analysis on this timed pattern. Okay, so let's move to the software now, and here we have our pit design. We have some survey strings for our blocks. Okay, so this is an input from mine planners, and what we're gonna do is we're gonna do a full design now, starting from scratch. All right, so the first thing we need to do is check if our surfaces are fine. As you can see, this one is fine, and also check if your outlines are available. Okay, which is this case. So if I just put the surface as triangles, you see that we have our outlines here, and I am going to work with this outline here. Okay, so I'm not using these other two, I'm using this one. Cool. Okay, so let's start fresh. Let's take everything out. I want to design a new drill pattern, which I will call webinar workflow. Okay, and I want to make it as a production pattern type. So now I have here my pit survey strings and my outlines. Okay, so as you can see, this is my pit and it's important to emphasize that this is a demo data, okay? So it's not as irregular as it's in real life, okay? So this is like playing surfaces. It's not it doesn't have any irregularities. Okay, so first step here is to create and assign our surfaces, okay? So I do have our color surface, which is this one, and it's our topography. So I am going to assign it as a color surface, which is the green surface now. And I have prepared some tools surfaces, okay? So if you click on this line, you see that this is 980 meters elevation. So this is the surface we need to activate from here, and we're going to use this as our excavation surface because this is our target, right? And as well as our pattern anchor. So what's our pattern anchor? You might be wondering, right? It's the point that the holes will be fixed. Okay, so where the drill hole intercepts the pattern anchor surface is the fixed point of a hole. If you move it from that point, it will move your X and Y position. So if you move a hole that's positioned here from the pattern anchored, it will move like this, okay? If you grab from the collar or the toe, it will change the angle. So it will stay fixed and it will change the angle that it's and the azimuth as well, okay? So that's why it's important to assign a pattern anchor surface. And in this case, I want to create another surface that it's minus 2 meters, okay, from this one. So it's 978 meters, and this will be our charge and drill, okay? And if you look closer, they are just a little bit apart, okay? So from a very far distance you cannot see, but if you take a look closer you'll be able to see. Okay, so we have now drill, charge, anchor, excavation, color surfaces, right? So we can turn them off, and let's save our changes, keep our data saved, and now we're gonna start drawing the design. Okay, so I will come to the grid hole pattern button on the holes tool, and I will select origin and the end of the first line. This is my boundary, and okay, these are the hole pattern configuration. So here you can add burden and spacing. Let's say it's a 4x5 staggered pattern, 89 millimeters, and I want the triangles icon. This will be the minimum valid length for holes. So as we don't charge on this case holes that are shorter than 5 meters, my minimum valid length will be 5 meters. Okay, the angle relative to the horizon is the angle of the holes. So if I have a slope angle of 10 degrees, here will be 10 degrees, okay, which is our case here, and this is just the multiples of the holes. If you want to change the angle, it will change from 0.5 to 0.5. So it will start in 10 and then you go 10.5, 11, and then it goes. If you put on 0.1, it will go 10.1, 10.2, and so on. Okay, and let's leave it at number 1. It's telling me now to select a site for the roll to direct the hole tools. So this is pretty much telling me, asking me actually where is what's your azimuth, and it's this. Okay, so as you can see, we have some holes here. Okay, and this is our drill pattern design. Okay, so it seems to be fine. I just want to delete this first hole here, and I want to label this one as 1, and then we're good to go. Okay, cool. So now we have our holes designed, and I want to show you quickly that you can change your numberings. Okay, so if you want to, you can unlock and remove, or you can just simply link 2 holes or multiple holes to respect the same numbering logic. Okay, this is a very interesting tool for clients that want to make a customized hole ID, and it's fine. Okay, it's a good tool. Now I am going to quickly show you the burden check tool. So first I need to get a sample from our topography, so I can use this as our face for the burden check. So I'm going to draw a polyline here, and I'm going to cut the topography. So this is my boundary, and this is the area to keep, and this is the topography. We have now a small surface. We're going to assign as a burden, and we're going to select these holes as our face holes. Okay, and we're gonna calculate. So as you can see, it has created, let me just deactivate this, the green lines are sections. Okay, so they are not a line, they are plane here that's cutting the hole, and it will show the distance from the hole to the surface and the closest point. In this case, our closest point is the stemming. Okay, so it's the surface itself, the bench, to the beginning of the hole, and this is all customizable as well, calculated according to the client's necessity, according to the client's calculation. Okay, so you can have factors that multiply the whole diameter to show you what's the safety distance here. These holes are a little bit far from the face, but it's fine. It's just a demonstration, right? So we can move these holes forward, and as you can see, we have this for all the holes. Okay, cool. So now we have our designed pattern, and I want to save it. And let's say by any chance that I have made a mistake with the hole diameter, right? So I can select these holes and I can change their diameter here. Okay, so this is a good tool actually to change if you forgot to change the hole diameter while you were doing the grid hole pattern. All right, so we save and we exit. Now I want to show you quickly how to export this whole data. So let me just deactivate this, as we don't need them anymore. So this whole data information, we need to export it, right? So you can drill this on the field with real information. So what you can do is, we have some drill navigation systems here like Leica, Atlas, Miplan, Cuttering, and Wenco modular. Or you can export as a CSV. This file is a CSV. Okay. Or you can also print a drill sheet to send to your operators, and they can follow the manual way. All right, if you want to, of course. Cool. And we do have an export session here, which is a little bit more complicated, so I'm not gonna dive in, but it's not complicated, it's just a more complete exporting tool. Okay, so you have a lot of other information that might not be relevant for the drilling. Alright, so now I am moving to the drill module. Okay, it's loaded now. Here on the drill module, it's important to emphasize that we do have BlastPad, and BlastPad is a tablet tool that you can take it to the field and record real information. Okay, and if you're in the same Wi-Fi, in the same network, you can bring live information from the field. Okay, so this is the importance of BlastPad in this step on this module. But also we do have other options to bring as drilled information from the field. Okay, so one of them is bringing from drill navigation logs. Another one is manual input from a drill log sheet that I'll show you just now. And as also we can do an integration with the drill navigation system database to DataBlast, and this information will come straight to our database. Okay, and then you don't need to touch the data or the information. There is no manipulation at all. You just press a button, it refreshes on the drill machine fault log here. It brings the information from the drill navigation system, and you just need to confirm if the information is fine or it's not, or if you think it's a mistake. Well, it's another option. Okay, showing quickly here the drill log. We just select drill rig and we input manually the drill depths. Okay, so let's start with 12.5, 13.5, 11, 13.2, and 10.5, let's say. Okay, so I have one inspec and two shorter, two deeper holes. I am saving now, returning, and I can show you quickly the report here. Let's put it at 0.5. You can see that these holes in red are shorter, the blues are deeper, and the red and the green one is inspec. Okay. Also, we do have another report that is fully customizable. It's distribution of the holes and how is the depth deviation for these holes, and also the color accuracy if you have captured the data for the color and toe coordinates. Okay, cool. So that's pretty much all we can show on the drill module. And always remember that we can do integration with the drill navigation systems. It can be manual inputs, or it can be bulk information through drill navigation logs. Okay, maybe a CSV file. And moving to the measure module now, it works pretty much similar to the drill. Okay, you can export and import from BlastPad. You can print a deep sheet with all the holes for the assistants to measure the holes, fully customizable as well. You can deep entry. So here we have historical data for the hole. This is the design and this is the as drilled, and you can type in here the measure depth according to the assistants that measured the hole. Okay, so let's say this was a little bit deeper than what the drill rig said, and this will be 12.8, and this will be 10.2 because it has collapsed, for example. Okay, let me just select an operator here, a shift, and let's say last week, someday. Okay, you can save, and you see that the new data is stored as current value. Okay, for holes 1, 2, 3, 4, and 5. Also here you can flag holes as backfilled, so it will automatically change the depth to the target depth if it's deeper. Okay, you can also generate a backfill sheet. It generates a pattern with all the holes that needs backfilling. In this case are 2, and it shows how much you need to backfill here. Okay, this is fully customizable as well. Cool, so let me just deactivate the backfill pattern and quickly show you the hole status. So you can flag holes as dewatered, as reactive if you want to, and you can generate the same report as I showed you on the drill, but now with deep data. Also, okay, so that's all for the measure as well, and it's not very different from the drill, but it's important to measure the holes because your holes might be collapsing, or your drill logs can be a little bit different from what's real, and then you're overcharging your holes. So that's why we do have a measure step here. Okay, going to the charge now. Let's do this part with first right clicking and adding a new charge pattern. Okay, it automatically puts the CP that stands for charge pattern. I am using a conventional. I am going to select my holes and I'm going to add them. I'll save the changes, and now I'm going to select a charge standard. That is a pre-made rule that makes your process so much faster. Okay, it's automated rules for holes that are dry, wet, or dewatered. From the length from 5 to 8 meters will be charged like this: 1.8 meters stemming and 3.2 emulsion with 1 primer. And if it's from 8 to 25 meters, it's a 2 meter stemming, 2 primers, and the rest is pumped emulsion. Okay, I have the same here because wet holes doesn't affect my emulsion in this case, and I am using an electronic initiation system type. You can change to non-electric if that's what you use in your site. Okay, cool. So applying the charge standard, and first I'm gonna show you the charge sheet that can be sent to the field for the blast crew, so they will know how much to charge for each and every hole. Okay, and what type of product they need to use. Okay, so we have also here a design depth and a drill depth and a deep depth for the real information to be fed. Okay, let me quickly show you the whole deck layouts. So let's see the first ones because I have changed the depth. So for example, 3 is shorter and it adapts the amount of emulsion we need, right? And the same goes for 4, but now it's cheaper. Okay, so of course you might want this to be as regular as possible on the real life. This is just an exaggeration to show how this can be recognized here on our tool. Okay, and you can see that it's shining blue here because it has new information to show. Okay, so this is the preview for charge patterns, Here I can do export and import from BlastPad. It also can be automatically fed because this pattern is flagged as live now. Okay, so it will be shown if you're in the same network. If you're not, you can use the offline mode, which is this one. And you can also input as-built data on the DataBlast platform. Okay, so you don't really need the BlastPad, but we strongly recommend you use a field tool because it makes the data more reliable. Okay, so I have now my chart pattern, right? I need to move to the initiation now and show you quickly. I just want to show you a pattern, initiation pattern that Aaron did last week. For example, this one. This is a non-electric pattern. Okay, so you have different delays here for the rolls and for the echelon. Okay, and you can use this surface chords that will separate the holes. But in this case today I'm going to show you the electronic method. Okay, so I create initiation pattern and I add these holes and I save. Alright, so as you can see, this is a different from the, it's a different top ribbon bar from this one. Okay, as you can see, this is the non-electric commands and this is the electronic commands. Okay, cool. So now I am going to define X and Y zones because I want to name this. I want to select these holes, the right hand, and I want to change this to OR. Okay, and this will be waste. Okay, so you can see that now I have a label here and a label here that defines my two different zones, and I can also change the color. So waste will be yellow and OR will be green. Okay, now let's put a different color. Let's put it red. So it has more contrast from each other. Okay, so you can set up these names, you can save, and now I'm going to do a selective blasting with these zones, right? So let me just collapse this, and I am going to go to the timing design now. Okay, so first thing is to select a timing object. For example, let's start with the OR, and let's say I want the OR to be blasted on this direction here. Okay, I need to swap the direction, and now I am going to use for the waste, which will be like this. Okay, so here is 0 and it will blast on that direction, and this is 0 and it will blast on that direction. Okay, so you have this blast and this blast. I can save the changes. You can force incremental timing if you want, and then you have the timing for each and every hole here. Okay, cool. So now I'm going to quickly show you some of the analysis. So let's see how the firing simulation goes, and you might see that it will start here and here at the same time. Okay, as I said, this is just a demonstration. Okay, so doesn't take this as the real life example. Okay, so there you go, you have the holes blasting one by one, and then you're slowly getting to this, to the central region here. Okay, so this is the holes blasted, and let me quickly go to the timing contours and so just see the contour lines. Okay, so you can see that this blast is going in this direction and this other one is going on this direction here. And another important information is the maximum instantaneous charge. Okay, so at 189 milliseconds, if I go down here, I have my maximum instantaneous charge. Okay, which are three different holes blasting on the same millisecond on the same time. So this is relevant information if you want to check it. That's where you check on DataBlast. Okay, now we're gonna see the vibration, where we can have some estimation for our vibration in millimeters per second. So this is our blast, and I already have some mobile monitors from previous blasts here. So as you can see, they are kept in case you want to reutilize them. Okay, but you can always delete it if you don't want to see. You can also add some fixed monitor points. Let's say you have always a monitor point on your crusher, okay, or in the office for safety purposes. So you can add them here, which is not our case. We don't. These are pre-made points for the north bit, not the south bit, so I'm not gonna use them. I'm going to create a mobile point, a new one, let's say here, and I'll call this one as mobile screening. Okay, so this is for measuring the vibration on the screening equipment, and these are the position X, Y, and Z. And also, if you want to set up the velocity, you have some constraints here, and of course it requires some calibration. Okay, but for this case, as it's just a demo, we're going to use the standard values, and as you can see, this point that is pretty close to the blast is giving us 21.3 millimeters per second, the maximum being 29.8. okay, and you can add as many as you want, so you just need to click and add here. Okay, so I have 3 points now, as you can see, and this is quite useful if you want to keep track of your vibration. We can always cross-check with the real values and do the calibration, so DataBlast will be very accurate to your real measurements. All right. So this is really useful for the pits that have neighbors, or it's under some strict regulations for the vibration of the ground, and it's quite simple to configure. So it's not a big deal. It's not rocket science. Okay, you just considers the distance, the amount of explosive going on the maximum amount of explosive, the maximum instantaneous charge, as we saw just now. And I think that's it for the vibration analysis. Okay, now we're going to back, and to remember that the vibration analysis is a tool that for many of our clients it's been useful. Okay, and that's it for now for the DataBlast. You can contact us on these emails here. So Aaron and myself and Inzaka, we're fully available to answer your questions or to give you some more information about DataBlast. Okay, I hope we talk again. I hope we can make some more webinars to talk about this wonderful tool that is DataBlast and how this can change your whole production scale, your whole production routine, and the benefits that this tool can bring to your mine and your operation is not measurable. Okay, some of the benefits is just not measurable, so it's very important for you to think about it and contact us if you need further information. We can make a full demonstration for you. Okay, we have some videos on the YouTube channel as well if you want to check them out. And I hope you've enjoyed our session, and thank you for the audience, thank you for the time and the patience, and I hope to talk to you guys again. Okay, have a good rest of your week, and be safe.